Hello everyone. In this session, we are going to do question number 1 to question number 4 of exercise 21E of the chapter Trigonometrical Identities from the textbook Concise Mathematics by Selina Publications for class 10. In case you want to refer to the answers of the previous exercises, the link is getting displayed on the screen right now. So let's now begin with question number 1. The left hand side of the question number 1 part 1 is given as 1 divided by cos A plus sin A plus 1 divided by cos A minus sin A. So here first we will take the LCM, which will be the product of the two denominators. So it would become cos A plus sin A multiplied by cos A minus sin A, and the numerator here will become cos A minus sin A plus the numerator here will become cos A plus sin A. Now minus sin A plus sin A will get cancelled out and we are left with 2 cos A in the numerator. The denominator is of the form A plus B into A minus B. So it will become A square minus B square, which is equal to cos square A minus sin square A. Now we will convert the sin square A in the denominator in the form of cos. So it can be written as minus of 1 minus cos square A. This is by the trigonometric identity that sin square theta plus cos square theta is equal to 1. Therefore, sin square theta is equal to 1 minus cos square theta. So it can be written as now 2 cos A. Cos square A will get added to this cos square A, so that would become 2 cos square A minus 1, and which is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as cosec A minus cot A. Now we will convert cosec and cot in terms of sine and cos. So cosec A can be written as 1 divided by sine A minus cot A here can be written as cos A divided by sine A. Now we will take the LCM, which is sine A, and the numerator will become 1 minus cos A. Now here if you will observe, we want 1 plus cos A in the denominator in the right hand side. So we will multiply both the numerator and denominator by 1 plus cos A. So the numerator now becomes 1 minus cos square A. This is because the numerator was here in the form of A minus B into A plus B, which is equal to A square minus B square. So it would become 1 minus cos square A, and the denominator will become sin A into 1 plus cos A. Now we know that 1 minus cos square A is equal to sin square A by the trigonometric identity that sin square theta plus cos square theta is equal to 1. Therefore, 1 minus cos square theta is equal to sin square theta, and the denominator will remain as it is, that is sin A into 1 plus cos A. Sin A will get cancelled now. So we are left with sin A divided by 1 plus cos A, and this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as 1 minus sin square A divided by 1 plus cos A. So here we will first find out the LCM. The LCM will be 1 plus cos A. Now the numerator here becomes 1 plus cos A minus sin square A. Now we will write minus sin square A here in the form of cos. So it can be written as 1 minus cos square A by the trigonometric identity that since sin square theta plus cos square theta is equal to 1, therefore sin square A can be written as 1 minus cos square A. Now we will open the bracket, so this will become 1 plus cos A minus 1 plus cos square A divided by 1 plus cos A. Now 1 here will get cancelled out and we are left with cos A plus cos square A, and we will take cos A common from here. So it will become 1 plus cos A divided by 1 plus cos A in the denominator as well. So this will get cancelled out. We are left with cos A now, and which is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of question number 4 is 1 minus cos A divided by sin A plus sin A divided by 1 minus cos A. So first we will find out the LCM, which will be the product of the two denominators. So it will be sin A into 1 minus cos A. The numerator here will get multiplied with 1 minus cos A. So that would become 1 minus cos A whole square by the formula of A minus B into A minus B is equal to A minus B whole square. And sin A will get multiplied with sin A. So that will form sin square A. Now we will expand it using the formula of A minus B whole square. So it will be equal to A square, that is 1, then plus B square, that is cos square A, and minus 2AB, that will be equal to minus 2 cos A. The denominator will be copied as it is. Now we know that sin square A plus cos square A is equal to 1 by the trigonometric identity. So we will write cos square A plus sin square A as 1, and 1 plus 1 will become 2. So this will be written as 2 minus 2 cos A divided by sin A into 1 minus cos A. Now we will take 2 common in the numerator. So it will become 1 minus cos A divided by sin A into 1 minus cos A. 1 minus cos A will get cancelled out in the numerator and denominator, and 2 divided by sin A can be written as 2 cosec A, as 1 by sin A is equal to cosec A. This is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as cot A divided by 1 minus tan A plus tan A divided by 1 minus cot A. So here we will convert cot A and tan A in terms of sine and cos. So it can be written as cos A divided by sine A divided by 1 minus sine A by cos A. Similarly, we can write it as sine A divided by cos A divided by 1 minus cos A by sin A. Now we will find out the LCM here, which will be equal to cos A, and the numerator here will become cos A minus sin A, and this cos A will get multiplied with the numerator. So this will become cos A divided by sin A multiplied by cos A divided by cos A minus sin A. Similarly, we will get sin A divided by cos A into sin A divided by sin A minus cos A. Now we will find out the LCM of the two denominators, but before that we will take out the negative sign common from this part. So it can be written as cos square A divided by sin A into cos A minus sin A. As we are taking out the minus sign common, now this plus sign will become minus. So minus sin square A divided by cos A into cos A minus sin A. Now we will find the LCM. So it will be sin A into cos A into cos A minus sin A, and the numerator here will get multiplied with this cos A, so it will become cos cube A. Similarly, the numerator here will get multiplied with this sin A, so it will become sin cube A. Now this is A cube minus B cube, so we will apply the formula of that. So it will become cos A minus sin A into cos square A plus sin square A plus sine A into cos A divided by sine A into cos A into cos A minus sine A. Now cos A minus sine A will get cancelled out here, and we are left with cos square A plus sine square A plus sine A cos A divided by sine A cos A. So we will divide each of these terms individually with sine A cos A now. So cos square A divided by sine A cos A, cos A and cos A will get cancelled out, and we are left with cos A divided by sine A, which is equal to cot A. Similarly, sine square A will be divided by sine A cos A. So sine and sine will get cancelled out. We are left with sine A divided by cos A, which is equal to tan A, and sine A cos A will be divided by sine A cos A. So both the terms will get cancelled out, and we are left with 1. And this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the sixth part of the question is given as cos A divided by 1 plus sin A plus tan A. So here we can write it as cos A divided by 1 plus sin A, and tan A can be written as sin A divided by cos A. Now we will find out the LCM. So it will become cos A into 1 plus sin A. This cos A will get multiplied here. So this will become cos square A plus sin A will get multiplied with 1 plus sin A. So it will become sin A plus sin square A. Now we know that cos square A plus sin square A is equal to 1. So we can write it as 1 plus sin A divided by cos A into 1 plus sin A. Now this is by the trigonometric identity that sin square theta plus cos square theta is equal to 1. So we have written 1 over here. Now this 1 plus sin A will get cancelled out in the numerator and the denominator. So we are left with 1 upon cos A, and this can be written as sec A, as 1 by cos A is equal to sec A, and this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as sin A divided by 1 minus cos A minus cot A. So here we can write it as sin A divided by 1 minus cos A minus cot A can be written as cos A divided by sin A. Now we will find out the LCM. The LCM will be equal to sin A into 1 minus cos A. This sin A will get multiplied here. So this will become sin square A, and 1 minus cos A will get multiplied with cos A here. So it will become minus cos A plus cos square A. Now we know that sin square A plus cos square A is equal to 1. So we can write it as 1 minus cos A divided by sin A into 1 minus cos A. This is by the trigonometric identity that sin square theta plus cos square theta is equal to 1. So we have written sin square A plus cos square A as 1. Now 1 minus cos A will get cancelled out here. So this will become 1 divided by sin A, and 1 by sin A can be written as cosec A, and this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as sin A minus cos A plus 1 divided by sin A plus cos A minus 1. So it can be rearranged and written in this form, that is sin A minus cos A minus 1 inside the bracket divided by sin A plus cos A minus 1 inside the bracket. Now we will multiply both the numerator and denominator by sin A minus cos A minus 1 Now the numerator has become of the form A minus B into A minus B, which is equal to A minus B whole square. So this can be written as sin A minus cos A plus 1 whole square divided by sine square A minus cos A minus 1 whole square. This is because the denominator is of the form A plus B into A minus B, which is equal to A square minus B square. Now we can write the numerator as sine A plus minus cos A plus 1 whole square, and this would be divided by sine square A minus cos A minus 1 whole square. Now we will apply the formula of A plus B plus C whole square in the numerator, which is equal to A square, that is sine square A, plus B square, that is equal to minus cos A whole square, that will become cos square A, plus C square, that is 1, plus 2AB, that will become minus 2 sine A cos A, minus 2BC, that will become minus 2 cos A, and plus 2AC, that will become plus 2 sine A. This would be divided by sine square A minus, now here we will apply the formula of A minus B whole square. So this will become minus cos square A minus 1 plus 2 cos A. Now we know that sine square A plus cos square A is equal to 1. So this will become 1 plus 1, that is equal to 2, minus, we will rearrange now the numerator such that the minus 2 cos A term is written before. So this will become 2 minus 2 cos A and plus 2 sine A minus 2 sine A cos A in one bracket. The sine square A minus 1 in the denominator can be written as minus cos square A by the trigonometric identity. So this will become the denominator now. This is by the trigonometric identity that sine square theta plus cos square theta is equal to 1. Therefore, sine square theta minus 1 is equal to minus cos square theta. So we have replaced the value here. Now from the first two terms, we can take 2 common. So this will become 2 into 1 minus cos A. And from the last two, we can take 2 sine A as common. So this will become 1 minus cos A. The denominator now has become minus 2 cos square A plus 2 cos A. Now we can write the numerator as 2 again can be taken as common. So this will become 2 into 1 minus cos A into 1 plus sine A. This is divided by 2 can be taken as common along with cos A from both the terms in the denominator. So this will become 1 minus cos A. Now 1 minus cos A can be cancelled both in the numerator and denominator. Also 2 will get cancelled out. So we are left with 1 plus sine A divided by cos A. Now here, as we need 1 minus sine A in the denominator, we will multiply both the numerator and denominator by 1 minus sine A. So the numerator has become 1 plus sine A into 1 minus sine A, which is A plus B into A minus B, which is equal to A square minus B square, that is 1 minus sine square A, and the denominator has become cos A into 1 minus sine A. Now 1 minus sine square A is equal to cos square A by the trigonometric identity, as sine square theta plus cos square theta is equal to 1. Therefore, 1 minus sine square theta is equal to cos square theta. So we have used the trigonometric identity over here. So the cos A in the denominator gets cancelled with the numerator 1. we are left with cos A divided by 1 minus sin A, and which is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the ninth part of the question is given as square root of 1 plus sin A divided by 1 minus sin A. Here we will multiply both the numerator and denominator by square root of 1 minus sin A. Now the numerator has become 1 plus sin A into 1 minus sin A inside the square root symbol. So it will be written as 1 square minus sin square A. That is equal to 1 minus sin square A, and the denominator has become 1 minus sin A into 1 minus sin A, that is 1 minus sin A whole square. Now 1 minus sin square A is equal to cos square A by the trigonometric identity. This is because sin square theta plus cos square theta is equal to 1. Therefore, 1 minus sin square theta is equal to cos square theta. Now we can take out the square root of both the numerator and denominator. So it can be written as cos A divided by 1 minus sin A, which is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the 10th part of the question is given as square root of 1 minus cos A divided by 1 plus cos A. So here we will multiply both the numerator and denominator with square root of 1 plus cos A divided by 1 plus cos A. Now the numerator is of the form A minus B into A plus B inside the square root sign. So that would become A square minus B square, which is equal to 1 minus cos square A. And the denominator is of the form 1 plus cos A into 1 plus cos A, that is of the form A plus B into A plus B. So that will become 1 plus cos A whole square. Now from the trigonometric identity sin square theta plus cos square theta is equal to 1, we know that 1 minus cos square theta is equal to sin square theta. So it can be written as sin square A divided by 1 plus cos A whole square. Now we can find out the square root of both the numerator and denominator. So it can be written as sin A divided by 1 plus cos A, and this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as this. So we can now write it as 1 can be written as sec square A minus tan square A, and the second expression would be written as it is. The denominator is also copied as it is. Now, this was by using the trigonometric identity that sec square theta is equal to 1 plus tan square theta. Therefore, sec square theta minus tan square theta is equal to 1. So we have replaced 1 with this. Now we will expand it using the formula A square minus B square is equal to A plus B into A minus B. So it can be written as sec A minus tan A into sec A plus tan A plus sec A minus tan A whole square divided by, the denominator will be copied as it is. Now here you can see in the numerator we have sec A minus tan A common in both the expressions. So we will take it out common. So this will become sec A minus tan A as common. So we have sec A plus tan A inside the bracket. And from the second expression, we will have sec A minus tan A inside the bracket. And the denominator will be written as it is. Here sec A minus tan A will get cancelled out in both the numerator and denominator. Plus tan A minus tan A also gets cancelled out. So this will become 2 sec A divided by cos sec A. Now sec A can be written as 1 upon cos A, and cosec A can be written as 1 upon sin A, because sec A is the reciprocal of cos A and cosec A is the reciprocal of sin A. So this is 2 sin A divided by cos A, and that is equal to 2 tan A, and which is equal to the RHS, and hence we have proved. The left hand side of the next question is given as this, so we can now write it as cosec A minus cot A whole square, and plus 1 can now be written as cosec square A minus cot square A. The denominator is copied as it is for now. The plus 1 here was changed into this form by using the trigonometric identity that 1 plus cot square theta is equal to cosec square theta. Therefore, cosec square theta minus cot square theta is equal to 1. So we have changed it in this form. Now we can take out cosec A minus cot A common from these two expressions in the numerator. This is because the second expression is of the form A square minus B square, which can be written as A plus B into A minus B. So this will become cosec A minus cot A whole square plus cosec A plus cot A into cosec A minus cot A. Here we have expanded this using the formula A square minus B square is equal to A plus B into A minus B. So this is divided by the denominator. So now we can take out cosec A minus cot A common from both the expressions here in the numerator. So this will become cosec A minus cot A, and from here we can write cosec A plus cot A in the bracket, and this is divided by sec A into cosec A minus cot A. Now cosec A minus cot A will get cancelled out in the numerator and denominator. Minus cot A plus cot A will get cancelled out. So this will become 2 cosec A divided by sec A. Now we know that we can write cosec A as 1 by sin A and sec A as 1 upon cos A. So this will become 2 cos A divided by sin A, and cos A upon sin A is equal to 2 cot A, and which is equal to the RHS, and hence we have proved. The left hand side of the next question is given as this. So here we will change cot A and sec A in the form of sin and cos. So we can write it as cot A is equal to cos A divided by sin A. So this will become cos square A divided by sin square A. Sec A can be written as 1 divided by cos A, as sec A and cos A are reciprocal of each other. So it will become 1 divided by cos A minus 1 in the numerator. and the denominator will be written as it is. Sec square A can be written as 1 divided by cos square A, as sec A is equal to 1 by cos A. The numerator here will be written as it is, and the denominator will become 1 plus 1 divided by cos A, as sec A is equal to 1 by cos A. Now we can further write it as cos square A divided by sin square A. Now here we will take the LCM. So the LCM will be cos A and the numerator will become 1 minus cos A divided by cos A. The denominator here will come as 1 by 1 plus sin A. Now we can cancel out cos A and cos A from both the numerator and denominator like this, and the rest of the expression can be written as sin A minus 1 divided by cos square A. In this denominator, we will take out the LCM. So the LCM will be cos A and the numerator will become cos A plus 1. So this will be written as cos A divided by cos A plus 1. Now from this, cos A and this cos A will get cancelled out. Now we will write sin square A here in the form of cos A as 1 minus cos square A, as sin square theta plus cos square theta is equal to 1. Therefore, sin square theta is equal to 1 minus cos square theta. And the rest of the terms will be copied as it is. In the second expression, we are left with sin A minus 1 divided by cos A into cos A plus 1. Now here in the denominator, we will apply the formula of A square minus B square, which is equal to A plus B into A minus B. So it can be written as cos A into 1 minus cos A divided by 1 minus cos A into 1 plus cos A into 1 plus sin A. From this, we can cancel out 1 minus cos A, 1 minus cos A, and the rest of the expression will be copied as it is. So now we are left with cos A divided by 1 plus cos A divided by 1 plus sin A plus sin A minus 1 divided by cos A divided by cos A plus 1. So here we will take the LCM. So the LCM will be equal to cos A into 1 plus cos A into 1 plus sin A. Now as we have 1 plus cos A and 1 plus sin A, both the terms here, so we will just multiply cos A with cos A to get the numerator. So this will become cos square A. Then as we have cos A into cos A plus 1 both in the denominator, so this term would be multiplied with 1 plus sin A or sin A plus 1. So sin A plus 1 into sin A minus 1 is equal to sin square A minus 1 square, that is equal to sin square A minus 1. This is by applying the formula A plus B into A minus B is equal to A square minus B square. Now we know that cos square A plus sin square A is equal to 1 by the trigonometric identity. So this becomes 1 minus 1 divided by cos A into 1 plus cos A into 1 plus sin A, and we know 1 minus 1 is equal to 0, and 0 divided by anything, it is equal to 0. So this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as 1 minus 2 sine square A whole square divided by cos raised to 4 A minus sine raised to 4 A. So this can be written as 1 minus 2 sine square A whole square, and the denominator can be written as cos square A whole square minus sine square A whole square. Now this has become a formula of A square minus B square, which is equal to A plus B into A minus B. So we will expand it. So this will become cos square A plus sine square A into cos square A minus sine square A, and the numerator will be as it is for now. So that is equal to 1 minus 2 sine square A whole square. Now we know that cos square A plus sine square A is equal to 1 by the trigonometric identity. So this will become 1, and the denominator can be written as cos square A minus sine square A into 1, which is equal to this, and the numerator will be copied as it is for now. Now cos square A can be written as 1 minus sine square A by using the trigonometric identity, that cos square theta plus sine square theta is equal to 1. Therefore cos square theta is equal to 1 minus sine square theta, and the numerator will be written as it is. So now the denominator has become 1 minus 2 sine square A, and the numerator is 1 minus 2 sine square A whole square. So this will get cancelled out now, and we are left with 1 minus 2 sine square A in the numerator. Now 2 sine square A can be written as 1 minus cos square A by using the trigonometric identity. So it will become 1 minus 2 into 1 minus cos square A, which is equal to 1 minus 2 plus 2 cos square A, which is equal to 2 cos square A minus 1, and this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as sec raised to 4a into 1 minus sine raised to 4a minus 2 tan square a. Now it can be written as sec raised to 4a into 1 minus sine raised to 4a can be written as 1 square minus sine square a whole square. So this has now become a formula of a square minus b square, and minus 2 tan square a is copied as it is. Now this can be written as sec raised to 4a into, here we will apply the formula of a square minus b square. So this will become a plus b into a minus b, which is equal to 1 minus sine square a into 1 plus sine square a minus 2 tan square a. Here now we can write 1 minus sine square a as cos square a by using the trigonometric formula that cos square theta plus sine square theta is equal to 1. Therefore cos square theta is equal to 1 minus sine square theta. Sec raised to 4a can be written as 1 divided by cos raised to 4a, as sec a is equal to 1 by cos a, and 1 plus sine square a will be written as it is. Now here we will cancel out cos square A. So we are left with 1 divided by cos square A in the denominator. Now this will become 1 plus sine square A divided by cos square A. So we will divide both the numerator here with cos square A. So this would become 1 divided by cos square A can be written as sec square A. Sine square A divided by cos square A can be written as tan square A and minus 2 tan square A. Now this will be sec square A. Tan square A minus 2 tan square A will become minus tan square A, and sec square A minus tan square A is equal to 1, as we know that sec square theta is equal to 1 plus tan square theta. Therefore, sec square theta minus tan square theta is equal to 1, which we have already got. So this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as cosec raised to 4a into 1 minus cos raised to 4a minus 2 cot square a. So this can be written as cosec 4a as it is. 1 minus cos raised to 4a can be written as 1 minus cos square a whole square. So this has now become a formula of a square minus b square minus 2 cot square a. Now we will apply the formula of a square minus b square here. So this will be written as cosec raised to 4a into 1 minus cos square a into 1 plus cos square a minus 2 cot square a. Now 1 minus cos square a can be written as sine square a. Cosec raised to 4a can be written as 1 upon sine raised to 4a, and 1 plus cos square a will be written as it is. Now this is because sine square theta plus cos square theta is equal to 1. Therefore 1 minus cos square theta will be equal to sine square theta. We know that cosec a is equal to 1 upon sine a, because cosec and sine are reciprocal of each other. So this will cancel out sine square a here and here. So we are left with 1 divided by sine square a, and this was minus 2 cot square a. Now we are left with 1 plus cos square a divided by sine square a. So this would be written as 1 divided by sine square a plus cos square a divided by sine square a minus 2 cot square a. Now 1 divided by sine square a is equal to cosec square a. Cos square a divided by sine square a is equal to cot square a, and this is minus 2 cot square a. Now cot square a minus 2 cot square a will give us minus cot square a, and cosec square a minus cot square a is equal to 1 by using the trigonometric identity that 1 plus cot square theta is equal to cosec square theta. Therefore cosec square theta minus cot square theta is equal to 1, and this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of the next question is given as 1 plus tan a plus sec a into 1 plus cot a minus cosec a. Here we will convert all the terms in the form of sine or cos. So let's start. 1 can be written as it is. Tan a can be written as sine a divided by cos a. Sec a can be written as 1 divided by cos a. 1 again will be written as it is. Then cot a can be written as cos a divided by sine a, and minus cosec A can be written as 1 by sine A. Now we will take the LCM in both the brackets. The LCM in the first bracket is equal to cos A, and the numerator will become cos A plus sine A plus 1. The LCM in the second bracket will be equal to sine A, and the numerator can be written as sine A plus cos A minus 1. Now we can rearrange both the brackets in such a way that sine A plus cos A are in the same bracket and 1 is separate. So it becomes a formula of A plus B into A minus B. So this can be written as sine A plus cos A whole square minus 1 square, and the denominator will become sine A into cos A. Now we will apply the formula of A plus B whole square in this bracket. So it will become sine square A plus cos square A plus 2 sine A cos A minus 1 square, that is equal to 1, divided by sine A into cos A. Now we know that sine square theta plus cos square theta is equal to 1, and this one will get cancelled out with the minus 1 over here. So this will become 2 sine A cos A divided by sine A cos A, and sine A cos A will get cancelled out with this sine A cos A. So this will be equal to 2, and which is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. In question 2, we are given if sine A plus cos A is equal to P and sec A plus cosec A is equal to Q, then prove that Q into P square minus 1 is equal to 2P. So we have written the given statements. Now we will begin with the left hand side of the part that we have to prove. So this is equal to Q into P square minus 1. Now we will put the values of Q and P in this. So it would become sec A plus cosec A into sin A plus cos A whole square minus 1. So this is equal to sec A plus cosec A. Now we will apply the formula of A plus B whole square in the bracket. So this will become sin square A plus cos square A plus 2 sin A cos A minus 1. Now we know that sin square A plus cos square A is equal to 1, and this will get cancelled out with the minus 1 here. So we are left with 2 sin A cos A in the bracket. Now we will convert sec A and cosec A in the form of sin and cos. So it can be written as 1 divided by cos A plus 1 divided by sin A, as we know that sec A is equal to 1 by cos A and cosec A is equal to 1 by sin A, and this will get multiplied with 2 sin A cos A. Now we will get sin A plus cos A in the numerator here, and the LCM will be sin A cos A, and we have 2 sin A cos A in the second bracket. So sin A cos A will get cancelled out. We are left with 2 into sin A plus cos A, and we know that sin A plus cos A is given as P. So this will become 2P. and which is the right hand side of the equation that we have to prove. So hence we have proved. The question number 3 is, if x is equal to a cos theta and y is equal to b cot theta, then show that a square divided by x square minus b square divided by y square is equal to 1. So here we will start with the left hand side that is given, that is equal to a square by x square minus b square by y square, and we will put the value of x and y from the given statements. So this will become a square divided by a square cos square theta minus b square divided by b square cot square theta. Now here a square will get cancelled out in the numerator and denominator, and similarly b square will get cancelled out in the numerator and denominator. So we are left with 1 divided by cos square theta minus 1 by cot square theta. Now we will change the cot square theta given here in the form of sine and cos. So it can be written as 1 divided by cos square theta minus cos square theta by sine square theta will become cos square theta here and sine square theta in the numerator. So this will become 1 minus sine square theta, and the denominator is equal to cos square theta. Now we know from the trigonometric formula that 1 minus sine square theta is equal to cos square theta. So it will get cancelled out now, and this will give us 1, and which is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. Question number 4 is, if sec a plus tan a is equal to p, show that sin a is equal to p square minus 1 divided by p square plus 1. So here we will start with the right hand side, that is p square minus 1 divided by p square plus 1. Now we will put the values from the given statement. So it will be sec a plus tan a whole square minus 1 divided by sec a plus tan a whole square plus 1. Now we will expand it using the formula of a plus b whole square. So this will become sec square a plus tan square a plus 2 sec a tan a minus 1, and in the denominator it would be sec square a plus tan square a plus 2 sec a tan a plus 1. Now sec square a minus 1 is equal to tan square a. So this can be written as tan square a plus tan square a plus 2 sec a into tan a, and in the denominator tan square a plus 1 can be written as sec square a. So it will be equal to sec square a plus sec square a plus 2 sec a into tan a. The numerator and denominator both are like this because of the trigonometric identity that 1 plus tan square theta is equal to sec square theta. So in the numerator we have used sec square a minus 1 is equal to tan square a, and in the denominator we have used tan square a plus 1 is equal to sec square a. So it would become 2 tan square a plus 2 sec a into tan a in the numerator, and 2 sec square a plus 2 sec a tan a in the denominator. Now in the numerator we can take out common 2 tan A. So we are left with tan A plus sec A in the bracket, and in the denominator we will take out common 2 sec A. So we are left with sec A plus tan A in the bracket. Now this will get cancelled out. Also the 2's will get cancelled out. Tan A can be written as sin A divided by cos A, and sec A can be written as 1 by cos A, that will become cos A in the numerator. So this cos A and cos A will get cancelled out and we are left with sin A, and this was equal to the left hand side, and hence we have proved that the left hand side is equal to the right hand side.